Hi, everybody. Welcome to the first session on reinforcement learning. So as I said in the email, it seems that we're not getting the recording. So I'm recording by Zoom. The quality might not be perfect. Hopefully you're going to get a result from the next session on. Okay. So today is the first session on reinforcement learning. So this is a course which we had given last time, last summer, not this summer, the summer before, 2024. And this year we're giving it in fall. So as I said, some of you might have been in the other course, the deep learning course. So we have this semester lots of visual topics, so we have particular 4 different ones. Just make sure that you are not in the wrong one. This one is F3, I guess. Third session on that, because all have the same code, course code, 1508. So you should see reinforcement learning somewhere in your course. So my name is Ali Beregi. This is my last name, but you probably are happier to call me Ali, and that's totally fine. It's called Ali. I'm one of you, okay? So you can find me in the same building, 7th floor. And also you can always write me an email if you have any question. We have TAs for this course, so we already have 4 TAs. One of them has changed just a few minutes ago, but we're gonna have 4 TAs, and they're gonna be tutorials for this course, like other courses, which I'm going to schedule next week, okay? So Tuesdays here in this lecture hall, on Fridays, same time, the other side of the stairs, okay? 1180, just pay attention to that one. I do know the other one is like Friday afternoon. This is the worst time ever, but I would be very happy to see you here. So now I'm pretty sure all of you already know about the details and how you get enrolled, but just as a kind of, heads up for those who might be for the first time at UofT. Once you get enrolled, you're going to get enrolled in the Curtis page. And this means that you have this opportunity to just get the materials of the course. Through that, you have access to Piazza, always the best place to ask me questions, or the TAs, because that is a kind of platform you cannot miss easily the questions of the students. And also the materials of the course, we used to have it always on Kirkus, but since this summer I started to just migrate the courses to their own course page. So you have access to the course page if you log into Kirkus page. I mean, I sent you a message, but you can check it also on the Kirkus page. So if you click there, you're going to get access to the original course page, and I'm gonna share all documents through that. So that's going to be easier to maintain for the next years. Feel free always to ask questions on those platforms, and that's pretty much about the basic logistics of the course. And then what the course is about. The course is about reinforcement learning. So it might be that some of you who are already here have a bit of idea about what reinforcement learning is. But if you don't have any idea, that's totally fine. If you just heard of it and it sounds good, cool, yeah, that's really cool. And then we're going to find it out through this semester. So how we are going to do it this semester, we're going to do it in 3 main steps. The first step that we're going to do, we're going to get the idea of the reinforcement learning framework. So it's a kind of online optimization framework in a nutshell, okay? So there are a bunch of definitions there. What is, for example, agent? What is environment? What is the interaction? What kind of information you are given, the kind of data that you have access through the process into, and what you want to do. What is the policy? What is the optimal policy? Things like this. So we're going to get a bit of idea about that. So we understand what is the RL framework. This is a very intuitive framework where you eventually do your where you basically formulate the online optimization problem there. And then once you understand this, you're pretty much able to describe an online optimization control problem in that framework. So this is something pretty much statistical, so you're not going to get too much of those, fancy learning terms. But this is quite important to get into the main idea of what reinforcement learning is. So once you get this one, this is a kind of warm welcome to the course at this part. Then we're going to get into step 2, which is essentially the tabular reinforcement learning part. So what is tabular reinforcement learning? It means that you look at data and you try to solve that online optimization problem. Data-driven. And now the point is that at this point, you're not using any neural network, any deep model, nothing like that, right? You're going to make a table. You just calculate a bunch of numbers, and calculating those numbers, you're going to get an idea about the right action to do. And this is what had been like the trend for a very long time till the deep learning became a kind of thing in 2010s. So we're going to go through the approaches there, and you might tell me that this is tabular. Nowadays, everybody's talking about deep reinforcement learning. But if you want to do deep reinforcement learning, there is no way to do it if you don't know what is tabular reinforcement learning. Because eventually what you do in deep reinforcement learning, you do tabular, but instead of using the table, you just replace that table by a neural network. That's it, okay? So this is the most important theoretical part of reinforcement learning course. And compared to other kind of machine learning courses, reinforcement learning is better established in terms of the mathematical background because it had been there in the control theory for a long time. And before deep learning became a thing, this had been eventually there. People developed all of those algorithms and used them and saw some outputs out of that. So in this part, we're eventually going to learn reinforcement learning in tabular form. You pretty much understand everything that you need to know about reinforcement learning at this part. But when I give you a problem in reinforcement learning, online control problem, you are able to formulate that one. You are able to tell me the algorithm or write down the algorithm, which is going to solve that problem statistically for you. But the point is that once you implement it, if you let it run for a practical problem, this is going to get forever. Yeah? Because that table that I told you, you can see that, but if you want to fill it out, probably you need to wait more than the age of this universe if the problem is something like chess playing. And this is where the deep learning is going to get in. So the third part is the deep reinforcement learning part, where we are going to revisit whatever we had in part 2, but this time we say, okay, this table, we cannot build it. We can just build it for dummy simple examples. But now that we have a realistic example, what we're going to do with that, okay, let's replace a neural network, right? So we're going to recap a bit of idea about like things like function approximation by neural network, things that you have had in the courses on machine learning or deep learning. And then that one is establishing that. We are going to revisit those previous methods, this time using a neural network. And this is going to end us up with different approaches. So there are particular approaches that we're interested in this course. So one of them is deep Q learning, deep Q networks, for instance, if you have heard of them. The other one is the policy gradient methods, where you try to learn the policy, what is the right policy to play. For instance, reinforced algorithm, if you have heard of it, or more sophisticated ones like PPO, GRPO. And then we finally get to the most practical one, which are active critic approaches, which use both Q networks and also the policy networks. Now, I do not expect you to understand any of these terms right now. Just to give you a hint, what we are going to explore in this course, but definitely you're going to get crystal clear about all these terms through the semester. Okay, everybody's cool? Cool. So for this part, you really need to have some background in deep learning, or at least have a very clear idea how neural networks work and how you can implement them. So if you have the other course, the 1513, it's a bit tricky, 1513, Introduction to Machine Learning, because I guess by the time we get here, you either have not started or just started neural networks there. Okay, now I'm not sure by the time that you need to do the assignments of this part, you are totally capable of doing it, given the information you get there. If you are very interested and you want to just challenge yourself by educating yourself, that's totally fine. But I just want to give you this hint here that you really need to have a good understanding of neural networks. If you have the other course, the applied deep learning course, that might be a bit easier because by that time you have a very good understanding of neural networks. But again, by the time you are doing the assignments, you might need to put a bit of more efforts there, right? So again, this is still up to you. It's not like I want to threaten you for anything. I would be more than happy that you take both courses at the same time, but just to give you a heads up regarding that, okay? So at this point, I can recap a bit of idea from deep learning, but I'm not gonna stick there because we have courses on that, right? We're not here to discuss deep learning. We are here to talk about reinforcement learning, okay? So for this one, knowing neural networks, knowing basics of deep learning is a must. And this part is roughly 50% of the course because as you're gonna see, the theoretical part is quite easy to grasp. The ideas are quite neat and clean. But when you get here, you're going to get into practical challenges. And we always need to come up with some tricks to somehow get over those challenges. So there are lots of algorithms here. So this is roughly half of the course, which you need to have, which we focus on the deep reinforcement learning. Okay, now this is a kind of high-level chart of what we're going to do in the course. So again, I don't expect you to understand any of this. We're going to have this chart a couple of times through semester till the end of the part 2. What we're going to do, we're going to basically look first into these two diagrams, which both are about tabular reinforcement learning. So if you're doing reinforcement learning, and you have your agent and your environment, then there are possible cases where, for instance, you know the model which is describing the whole interaction, like how the agent is interacting with the environment. When it does some action, how does the environment react? You might have such a case. This is what we call it model-based reinforcement learning. And there are a bunch of theory for developing the optimal strategy there, which are basically development optimality constraint and how you can, using that to find the optimal approach. And in that sense, you're going to end up with two basic algorithms, which are value iteration or policy iteration. So this is what we call it model-based tabular. You could have model-free tabular one, which is the case where you do not have any idea how the environment works. So it's like you just can try the environment. You can just play around with the environment and get a feedback from the environment, but you don't have any concrete understanding or mathematical model of the environment. This is what we call a model-free reinforcement learning. So the whole process is free of the model, and the only thing left is data and interaction. So in that sense, that there are different approaches to deal with such scenario. You can go on policy. Again, you're not supposed to understand what I'm saying. Just to give you a heads up. You might go on policy, you might go off policy. You might use approaches like temporal difference. You might use approaches like Monte Carlo to do some estimation here. And all of them are going to end up with different algorithms, a couple of known ones like Q-learning or SARSA. Like state action, reward, state action. And then these algorithms, all of them are totally free of deep learning. There's no deep learning here, right? So once we are over with part 2 of the course, you basically have a very clear idea of both columns of this chart, okay? And now the point is that if you want to really use any of these ideas that you have seen in these charts, for a practical scenario, like for example, playing a real board game with your computer, then you're going to see that computationally they're infeasible to implement. And this is where the deep learning is going to show up, right? So you're going to somehow apply deep neural networks on the same algorithm, on the same approaches, in order to just get an approximate of those approaches, right? And we can develop deep reinforcement learning algorithm for both cases, model-based and model-free. But in this course, we are going to mainly focus on model-free because this is the one which is realistic and practical. Like model-based is just a theory. It's not really happening in practice. Okay, so this is a very, very, very high level summary of what we're going to do in this course. I totally understand that many things here in this chart is not clear. I don't expect it to be. If they are totally clear, probably you should not be here. You should be on my place. But anyways, don't worry. We're going to get totally clear about that. Okay? Everybody's cool? So this chart, we're going to see it a couple of times. So each time we just finish with one part, I'm going to recap this. I'm going to give it to you again. Hey guys, we did this. And you're going to gradually build, get completely clear about that. Okay. Cool. So any questions? Any concerns? No question. Okay, cool. So if you got no question, like any courses, we have three major components: assignments, exam, and final project. So there is no final exam, just one midterm exam. The final exam is replaced by the final project. So the assignments, we have around 13 weeks, right? So plus one extra week, we're gonna have 14 assignments, okay? Joking, just 3 assignments. So we have 3 sets of assignments. Pretty much each of them is just covering one of the parts. So the assignments, I made them less here because the project is a bit more serious in this course. So you have only 3 sets. And the first one is basically going through the fundamentals, like formulation, you understand. You just apply those definitions that you have for some simple examples, and you just get some, rough conclusion out of that. That's going to be the first assignment. Also there, I try to give you a few, questions by which you can use them. They're optional questions, but you can use them to just recap what you need to know as background. But then after that, we're going to get one assignment on the tabular one. So there you get the chance to implement a couple of tabular algorithms to do a bunch of experiments. You're going to get to know the gymnasium environment where you can actually implement. There are predefined environments, or you can get your own environment implemented there, and you can use that to run your algorithm in the environment, simulate the environment. And then finally, you're going to get the last one, which is basically on the deep reinforcement learning. So one thing here is that deep reinforcement learning could be computationally very, very complicated, very high. Like you need to have access to good GPUs if you want to see like physical results. So the assignments are designed so that you can do it with your own computers or at the facilities available at ECE. But somewhere in the course, we discuss it, but if you really want to try it, you really need to have access to more sophisticated computation resources. So I do not put it as a kind of mandatory part of the course, but I will give you as a idea how you can try it. So for this course, this is not, you're not learning deep learning anymore, right? So we are not going to accept anything like, oh, I forgot this final activation, or I don't know, this code is not running because dimension is not matching. Such a thing is not accepted anymore. If it's not running, it's not complete. Sorry for that. So pay attention. It's supposed that you have a good practice. You have had a good practice on implementation. That one thing. So for the assignments, you always have a deadline. The deadline is always 2 weeks plus after the assignment is uploaded, and then by the time of the deadline, you're going to get the full credit. You can have 2 days of DLA, but for each DLA, you're going to get the 10% deduction from your final grade. Okay, so that's it. Oh, 3 days here. No, sorry, 2 days. when I was revising, I forgot to fix it. Okay, 2 days. And you understand that in the first version of the course, it was 3 days. But no, it's 2 days. Okay. Now, regarding the midterm is going to be on Tuesday. So we have Tuesday and Friday. So the Friday is reserved for the midterm of the other course. So since some student might have both courses, and also it's hard for me to take 2 exams on one day. So we're going to have it on the Tuesday. So it's going to be the Tuesday of the week exactly before the reading week in this semester. Okay, it's week 8. And that's going to be pretty much covering the first 2 parts. So the deep oral part is not going to be in the exam, just the tableau oral one. And in the exam, you're not going to get any question on programming. You're not supposed to write down an algorithm, things like that. You're basically doing just, a question that you can do it by hand. Okay. So that is 25% of the whole mark. And here, my exams are always super easy. Everybody knows. So you really need to just get the idea, right? And then you can simply answer the questions. We're not going to give you like super complicated question. This is just that you try your understanding of the main concepts in the course. And then it comes to the final project. And for the final project, this guy is going to replace your final exam. So we don't have a final exam anymore. We have a final project. And this means that I'm going to be very picky with that. So I'm going to go over your GitHub repository. I'm going to check your report with very much details. And it takes me a lot of time, but I always do it because this is the one which is trying to evaluate your complete understanding of the course. So how it works, I mean, given the course size right now, I believe the groups should be of size 4, but we're going to see, okay? But right now with 120 students, so 30 groups make sense. So we're going to have groups of size 4. So you're going to make groups. And then once you make the group, you are going to define your topics. So for the topics, I'm going to share with you by roughly week 3, so in 2 weeks at most, I'm going to give you some predefined projects. So these predefined projects have their own milestones, have their own target tasks that you're supposed to do. And you can take one of those predefined projects, but if you have any idea, you want to do any open-ended project, you're totally welcome to do that. But if you want to do that, then you need to, just check those, reference projects, and your project should be put in the form that is somehow consistent with that kind of, that level of the project being proposed, okay? So if anyone has any idea already in mind that I want to build this kind of agent, that's totally okay. You're more than welcome to do that. But just wait till we have the proposals out, and then you take a look, you prepare your proposal like that, and then you submit it by week 5, okay? So that's it about the project definition. Then you're gonna have one progress briefing on week 10. So on week 10, you are going to just write down what you have done, what is your conclusion. Probably you have done some research on the kind of implementation, the kind of environment you are going for, your maybe option A, option B, option C, whatever that is. You're going to write it down in a very short briefing in the template of your report, and you're going to submit it just as a kind of hint that we have started working, right? And we have some rough conclusion of what we're going to do, because on week 10 you have only 1 month left to the end of the semester. And then by the last week, you're supposed to finish your project, which includes a final paper, your slides, which you are going to present in 5 minutes, and also your Git repository. So we used to have this option that you just submit the code, maybe the zip file or something like that. But now we're just suggesting that the group makes a Git repository, a public Git repository, if you don't have any like IP issue, but if you have, you can just make your group private and then include us into the group into the repository, and then you start working on that. That way we can at least track your comments, we can at least track develop of your project, and that is the easiest way for us to access your project when you are over and evaluate. Okay. Any questions? Everybody's cool about the final project? Okay. So now regarding the programming, I mean, you can guess Python is the main language that we're going to use here. So we're going to use Gymnasium here as well, but you're not supposed to know Gymnasium. So the TA is going to just explain you, I mean, gonna give you do some examples for you in the tutorials, and you're gonna get familiar with the Gymnasium as well. You're gonna get some assignments with some draft codes that you can use them to just get practice in Gymnasium. So that part is not really needed to be known, but you need to know PyTorch, right? If you don't know it, if you're used to other platform, that's totally fine. Just try to tune yourself with the course. I mean, the assignments are considering PyTorch. If you are happier with another library, you can use your own library, but then this means that you need to write your code from script. Now, as I mentioned before, knowing deep learning, having some experience in that is a quite important thing. I mean, this is why we have it as a prerequisite here, but you are not going to directly use deep learning up to the midterm. Basically, you're going to use it in the last part for getting to deep reinforcement learning. Okay? Questions? No question? Okay, yeah. This is about the Gymnasium, so we're going to talk about it quite a lot in this course in the assignment, so you're going to get the understanding about that, and that's going to be the overall calendar of the course. This is how the whole course is going to get progress. So we're going to have 3 assignments, and then you're going to have 3 particular items for your project, and then that's it. Questions? No question? Okay, great. So one thing I forgot to put in I usually put in the logistic slides, I don't know why I forgot to put it here, is about the use of ChatGPT. You do know that I have this power to understand who has used ChatGPT. Didn't you know that? So anyone using ChatGPT, I find out, right? No, I'm lying. I cannot do it. Okay. So if you give the assignment to ChatGPT and ask it to just solve it for me, it's gonna solve it perfectly. I do know that. And I'm not going to lie, I cannot find out, right? So that being said, the assignments are supposed to be done by you because they are going to help you a lot to understand the concepts, right? So they are not there for you to just give you some extra marks. They are there for you to just, recap the course contents, and you get the understanding very well. So it's totally fine that you use ChatGPT. It's totally fine that you start writing your code, you see errors, you ask it what is happening here, and it's going to help you. But just blindly copying it there and getting the result is not a good idea. But I'm not going to lie. I'm not going to follow. I cannot really track it. So that's totally your choice. But my suggestion is that you rely on yourself, and then you just get it as a kind of useful help for accomplishing that items. Okay, so any questions? No question? Yeah.
Do all of the assignments have equal weightage? They're all worth 14% each.
Sorry?
Do all of the assignments are?
Yes, they are. Yeah.
For the assignment due dates, are you still finalizing those? It's just the general week right now, or is there a specific date?
This is a rough, at the end of each week, I'm gonna upload it. But usually I'll wait till I get to the part where the course is over, yeah? So it might be a bit back and forth, but yeah, I'm roughly the same. Any other, yes?
If assignments are done independently,
Sorry, yeah, sign is independently, of course, yes. The project is a group submission, of course. Other questions?
In the midterm, we will cover like the week 8 contract.
Week, yes, of course, week 7. It's on week 8, so it's gonna be up to the week 7. Yes,
When you say for the project submission, you're going to go through our Git, is like, are you personally going to?
yes, I personally go to your Git repository and I click on that, like 20 comments, and I read first what kind of comments you have done, then I compare to random comments, like, if I want to tell you, spoil what I do, yeah, but, yeah, I mean, of course, definitely you can run away from my eyes, and it's not like, you know, detective and stuff, but I take a look, I see the amount of effort you have put, and I don't care really about the final product, I just care about how well you have tried your best to develop that result. So don't be afraid to just go for something very big. If you rely on yourself, if it doesn't work at the end, it's not going to majorly impact your grade. Other questions? No question? Okay, so if you got no question, then yeah, regarding the prerequisite for the course, so you do know that deep learning is a prerequisite. I said it a couple of times, but rather than that, you don't need to know anything else. Anything else, we're going to build it here in the course. So I do know reinforcement learning as compared to many other machine learning courses, it has more math, but math with me is very fun. So you don't need to run away from that. So I'm gonna make it as funny as possible. And other backgrounds, all gonna be contained in the course. So linear algebra, calculus for all the theory I expect you to know, but very, very basic. If it anything new, I'm gonna explain it in the course. You are always welcome to ask questions or not. You should not be afraid of asking even very basic questions. So now for the resources, the first textbook, Reinforcement Learning by Sutton, that one is Sutton and Prato. Okay. The first textbook by Sutton, that one is quite, very, very well-known textbook. So pretty much reinforcement learning became a kind of framework after this text. So after this manuscript. So he has done, like he spent most of his life developing a framework for reinforcement learning very concrete. And the first 2 parts of the course are very well in line with the corresponding chapters of this book. I'm going to tell you after every single chapter which parts you can take a look at the at the textbook. But at the end of the day, I'm going to contain all the things you need inside the lecture notes. So if you want to prepare for the exam, if you want to do assignments or the project, you really don't need to read the book. But if you really want to know more or get a better understanding, I really suggest that you go ahead and take a look at this one. The good thing about it is that it's available free online, so you can always download it, take a look there. So there are other textbooks as well. There are this second one is actually one quite old but well-known preprint on famous RL algorithms. So is a kind of good summary if you want to take a look. And the Lapin textbook is actually one of those hands-on textbooks which are better received in the community. So if you want to know some coding stuff or some sample implementation, you might take a look at this one. But I guess this was for the era before ChatGPT. Today ChatGPT can help a lot, right? So, but this one is quite well-known textbook in that sense. So, any questions? No questions. I will like every other course. So we're gonna make the contract, right? So the contract is between the instructor, that's me, with you, all of you, and I'm gonna reserve this right for myself to modify the slides. Last minute before the course, this is always happening. I'm sorry, but yeah, find typos, right? And it might even happen after the course. Like if I find some typo which is very, very bad, like you're gonna make something wrong, I'm gonna fix it later on. But I'm gonna give you a heads up about that. So that being said, the best idea with me is always that you download the corresponding lecture right before the course. Because if you just download it like 2 days ago, it might be that I have changed it, okay? Don't do it. This is one thing, and the other thing is that I'm going to just deliver them in the mini batch form, like section by section, if I'm very generous, that's some chapter, one chapter, right? So I'm not gonna give you all the lecture notes because I'm gonna have lots of typos, okay? And it might be that at some point I just want to revise the lecture note, given what happened with the lecture, right? So, yeah. But you always get what you need for every single lecture before the lecture. Definitely that's gonna be. Everybody's cool? No problem? So we just sign it right now. Okay, and we are good to go. Yeah, I think some of you are, tired of Bloom, right? But for those who don't know him, anyone by any chance, I mean, in the other lecture, nobody knew him. Anyone by any chance knows who Bloom is? No, okay. So there was one series when I was a kid, Adventures of Gulliver, and this was these guys were the tiny people in that series. And each of them had a characteristic, and this guy was Bloom, who was like always like negative about everything. So asking question, does not buying anything. And he's going to be with us through the whole semester. So I am going to take Bloom as the reference when I'm teaching. That being said, it means that I always think about the people who have zero information on the topic, who have a very moderate rate of learning, exactly like myself when I was a student. So this means that some of you who have a bit of background might find some parts of the course a bit boring, but that's okay. Please be a bit patient because this is going to help everybody to capture the content, right? And if we want to just finish all together, we need to just be patient for everybody on the way. Okay? So sorry in advance if sometimes I do over explanation, but I want to just make sure that everybody is on the same page. Okay, so that's it. And final thing, yeah. As I said also morning, no such thing as a stupid question, and this is not something that I said. You can check the Wikipedia page of this particular sentence. So there is nothing that you can ask me and it sounds stupid, right? Now, the only stupid thing that you might hear is that this is a stupid question, right? This is stupid, right? Because if this question is stupid, then you need to be able to answer it, right? If you cannot do it, then you're gonna say, it's stupid because you cannot answer it. And I'm not that person, so you don't really need to be afraid. You can always ask questions, even if it's very basic. That's totally understandable. Many people might get lost at some point, right? So don't be shy. Don't feel like and this is very silly. I shouldn't ask. So always ask. And this is very important that you feel that you're understanding what is going on, because if you don't understand it, then it's gonna be just me talking to you, listening, and nothing happening. Okay? So it's very important. It's also important for me because it can help me just interact with you through the lecture. Any questions?